Hello dear students, welcome back to Physics Online Bridge Course classes. So in last videos, we are discussing about that. So applications of dimensional formula. So from that applications of dimensional formula, totally we got 3 applications. So I will make you remember once again. So in case of dimensional formula, by taking use of dimensional formula, we can check the correctness of the given equation. So that is first application. Second thing is, to convert from that one system of unit into other system, we are going to use the dimensional formula. And third use, so from the help of dimensional formula we can derive the equations. Though then what are the applications I can list out here? To check the correctness of the equation, and second application is to convert one system of unit into other system, and third application is, so in case of the dimensional formula we can able to derive certain kind of equations. So now we will be focused on what are the limitations of those dimensional formulas. So it carries certain kind of limitations in case of dimensional formulas. So the first limitation I got. So what are the limitations of dimensional formulas here? So dimensional formulas doesn't give any information about that dimensionless constant in the given formula. For example, in order to derive that equation, so time period of oscillation of simple pendulum, so that equation is 2 pi into square root of L by G here. So in order to derive this equation, so 2 pi is dimensionless constant. From the dimensional formula, so it doesn't give any information about that dimensionless constant. What is the first limitation here? So in case of the dimensional formula, it doesn't give any information about dimensionless constant in the formulae. So we are discussing about that limitations of dimensional formulas. So what are the limitations here? Limitations of dimensional formula. So what's the first limitation I get it here? So dimensional formula doesn't give any information about dimensionless constant in the given formula. So dimensional formula so does not give any information about dimensionless constant. So that is one limitation. So another limitations from the dimensional formula is, so dimensional formula is not applicable if the formula contains any trigonometric function and as well as logarithmic function. So remember here, dimensional formula method is not applicable if that equation consists of trigonometric function and logarithmic function. So we are unable to derive so the equation if that equation consists of trigonometric function as well as logarithmic function. So dimensional formula is not applicable if equation consists of trigonometric function and logarithmic function. Logarithmic function here. So these are all the limitations under dimensional formula. So hope you got about that dimensional formula. So since from the first video, so we got how to write the dimensional formula, and in case of dimensional formula, so some physical quantities having the same dimensional formulas, and so we are going to consider M, L, T. So in case of classical mechanics we will use these three terms, whereas in case of dealing with the temperature, M, L, T and K here in terms of temperature we will use, and in order to discuss about that current here, so we'll use ampere. So in that next upcoming classes in second PU you will use the term ampere, so I didn't explain about those things. So M, L, T and K. By using these four terms, we can able to write the dimensional formulas of respective given physical quantities. So now today we will be discussing another interesting chapters related to measurement. So already in first videos only we discussed that. So what you mean by measurement here? So measurement means the process of comparison of a physical quantity with same unit, you said. Okay, right. So what's the purpose of measurement? So physics always needs exactness, means we need that exactness. That exactness comes only from the measurement, I said. Okay. So in order to get that exactness, measurement is required here. That measurement is done by instruments only, right? So whatever the measurement you are going to perform, that measurement is with the help of instruments. Okay. So if the measurement is with the help of instrument, means I need that measuring scales here. So in order to measure the physical quantities, so we are getting certain kind of uncertainty while measuring the physical quantities. So look at here. So in order to measure the physical quantities, we are getting uncertainty. Uncertainty means not perfectness, we can call. So that uncertainty we will name by errors here. So in physics, that is important terms. So that important term is error here. So look at here. In case of measurement, we said that, so for that exactness, we will use to measure the things here. In order to measure the things, we will use measuring instrument. Okay. So in case of that measuring instrument, so that measuring instruments will give certain kind of uncertainty. That uncertainty we will name by errors here. So that uncertainty I will give the name errors here. So from today onwards, we will be focusing on errors here. So that is also part of the dimensional, means part of that units and measurement here. So in case of that units and measurement, already I got that. So what are the fundamental units, derived physical quantity and a dimensional formula. So applications of dimensional formula and limitations of dimensional formula, I got that. So now we will be discussing about that errors here. So look at here. In case of measuring the physical quantity, we are getting certain kind of uncertainty. That uncertainty I will name by errors here. So errors, or simply you can call it as error here. What's the mean of that error here? So let me give one generalized example. For example, true length of this object is 10 centimeters. So what's the true length here? So true length of this object is 10 centimeter. If I give this same object, so I assign one work for you. So measure the length of this object. So while measuring, so you are getting that answer as, for example, what's the true length here? True length is 10 centimeter. So if I give this object and if I give that measuring scale, so that measured value will be measured value not exactly 10 centimeter. You may get that sometimes 9.9 centimeter, for example. So you are getting measured value is, so if you measure this length, you will get that answer, for example 9.9 centimeter. Then what's the difference here? So that error means the difference between true value and measured value. What do you mean by error here? The difference between true value and measured value here. So what's the true value here? True value of this object is, means true length I can take. So true length is 10 centimeter here. While measuring, I got that 9.9 centimeter here. So 0.1 centimeter. So this 0.1 centimeter is nothing but that is error while measuring. So hope you understand the mean of error here. So how will you define that error here? So error, I can define it as, it is the difference between true value and measured value. So what is that error here? It is the difference between true value and measured value. So I can call this one as the difference between true value and measured value. The difference between true value and measured value, we can call that error here. So let me give one example, another example. So true length, so true length is 10 centimeter. While measuring, for example, if I measure first time, I will get that answer as 9.9 centimeter, and if I measure by that second time, I will get that answer as 9.8 centimeter here. So okay, which one is very much closer to the true value here, 9.9 or 9.8 here? 9.9 is very much closer to the true value here. So this method means this phenomenon I can call it as accuracy here. Which is more accurate here, 9.9 or 9.8 here? 9.9 is more accurate here. So what's the mean of accuracy here? Closeness to the true value, I can call it as accuracy. So remember the term here, I will use accuracy here. What's the mean of accuracy? Closeness to the true value. So look at here. So these two are observed value or measured value, 9.9 and 9.8 centimeter. So compared to these value, so 9.9 centimeter is very much closer to the true value. So that 9.9 centimeter is more accurate here. Then I can able to define another term here. So that is accuracy. Accuracy here. So what is that accuracy here? Closeness to the true value. Closeness to the true value. Closeness to the true value, I can call it as accuracy here. Next, one more term I will use, so that is precision. So what is that another term here? Precision here. So what's the word mean precision here? So look at here, I will give you one normal scale here. So take that length is 0 to 15 centimeter. So here 1 centimeter is there. So between 0 and 1, how many digits are there? So it consists of 10 digit here. Okay. So what's the value of one digit here? So did you get my point? So from 0 to 1, 10 lines are there. I want to find out what is the value of one line here. So that is least count here. What is the least possible measurement from this scale here? So look at here. So this is 1 centimeter. I will write it as a 1 here. From 0 to 1, how many lines are there? 10 lines are there. So 1 by 10. So that is 0.1 centimeter here. So look at here. What is the least possible measurement from this scale? From this scale, I can able to measure smallest distance is 0.1 centimeter here. So one more scale is there. So in first PU you will learn, means you are having that experiments. So that is vernier caliper. So that is one instrument. So from that instrument you are getting that least count, means that least count of that experiment, means that equipment is 0.01 centimeter. So it measures smallest distance 0.1 centimeter. It measures smallest value is 0.01 centimeter. So which one will give the more accurate value? By this one we can get that more accurate value. So its limit is 0.1 centimeter. So from the normal scale, if the distance is less than 0.1 meter, this scale is not applicable here. Why? Because least distance I can measure is 0.1 centimeter. So less than 0.1 centimeter length we cannot able to measure from this normal scale. So for that purpose we will use another scale. So that is vernier calipers here. So that vernier calipers will give that accuracy. So about that 0.01 centimeter here. Now I need to understand the term precision here. So in case of that precision, so for example, I give a normal scale and vernier scale example here. So in order to define that precision, the limit to which physical quantity can be measured. So for example, what is the limit for this scale? 0.1 centimeter is the limit for this scale. For the vernier calipers, what is the limit here? 0.01 centimeter. So this much of small distance I can able to measure from vernier calipers instrument. So that is the limit of vernier calipers instrument. So precision means the limit to which a physical quantity can be measured. So that is about precision here. So hope you understand these three terms. Now I will be focusing on about that errors here. So look at here. In case of errors, there are two types of errors are present. So one is systematic error and another one is random error here. So in case of errors, there are two types of errors are present. So let me look at what are the types of errors here. So we'll understand about that types of error. So In case of that error, first one is systematic error. And second one is random error. Okay. So now we'll understand in case of systematic error. So systematic error means errors due to definite reasons, means so we know why the errors are occurs here. So that kind of errors I will take it as systematic errors here. So what is that systematic errors here? Errors due to definite reason, I will call it as systematic error here. So look at here. So I will understand about that systematic error first. What is that systematic errors here? So errors due to definite reasons. Errors due to definite reason. So that is systematic error. So we know the reason for the errors here. So such kind of errors are belongs to systematic error. Again, in case of systematic errors, there are certain types of systematic errors are there. So what are the types of systematic errors I can understand here. So in case of systematic errors, so we can consider what are the types of systematic errors here. So in case of systematic errors, so I will consider that types of systematic errors. So in case of systematic errors, I can consider that, for example, errors are occurs due to fault design in the instrument. So look at here. So I am getting certain kind of errors while measuring the physical quantity. I said that true length of this object is 10 centimeter. Okay. So if you start measure that length of this object by taking one scale here. So while measuring this length, so whatever the scale you are using, so if suppose if that scale is bent, or if that numbers are not at all appears clearly, then you are getting certain kind of errors here. So look at here. So while measuring the physical quantity, so we are going to take use of that instruments here. So whatever the instruments you are using there, so if that instrument itself, it has certain kind of fault here. So due to fault designing of the instrument, you will get the errors here. So that belongs to systematic error here. So what is the first means? The first type I can consider fault design in the instrument. So what is that systematic error here? In case of systematic error, so errors due to definite reason. What's the definite reason? First reason, maybe so that instrument is somewhere wrong, means that instrument is getting fault here. So due to fault designing of the instrument, you will get certain kind of error. So that is one agreeable error here. And second thing is, so because of that our negligence, for example, if you are not observing that properly, so then also we will get that certain kind of error. So for example, if you are not observing clearly digits here, you will get certain kind of errors. So that kind of error we'll call it as personal error. So second one is personal error. So what is that personal error? Due to our negligence. So if you are not looking that reading in a proper way, we will get certain kind of error. So that error is belongs to personal error here. So next one we will take that. So due to change in weather condition also, we will get certain kind of errors here. So that kind of error is environmental error here. So look at here. In case of that error, so in systematic error I said, because of definite reason only we will get certain kind of errors. So I know the reason for the error. Such errors I will call it as systematic error here. So in case of systematic error, the first reason for getting error is, for example, due to fault designing of the instrument. Second reason, so if you are means if you are not taking the reading properly, you will get that certain kind of error. And third reason is because of that weather condition, you will get certain kind of error. So such kind of error we can call it as environmental error. Environmental error here. So I will give one general example. For example, if you are performing that Ohm's law experiment, right? So while performing that Ohm's law experiment, temperature should be constant. Why? Because if the temperature of the conductor is getting increased, means resistance value will also getting changes here. Okay. So for example, treat that if that Ohm's law experiment, if you are performing on a summer season. So for example, at summer season, maybe temperature is around about 50 degrees Celsius, very hot temperature. So in that surrounding temperature is 50 degrees Celsius. The same experiment if you perform on winter season, so temperature may be 10 degrees Celsius. So because of the change in weather condition, you will get certain kind of errors. So such kind of errors I will name it as environmental error here. So because of that change in weather condition also I will get certain kind of errors here. So such kind of error I will take it as environmental error here. So these are all belongs to that. So systematic errors here. So we know definite reason for that errors here because of the fault design of the instrument, because of our negligence, because of that environmental changes. So because of these things we will get certain kind of error. So that belongs to systematic error. Then we'll look after about what we mean by that random error here. So for example, so I will give you correct instrument only. Okay, I will set that proper surrounding environment. I don't want to change that environment also. And so you are too much careful while measuring the things. So I'm not making any kind of mistakes here. So I'm taking correct instrument and I'm not doing means I have hope I will not show any kind of negligence while measuring the things, and so environment is not changing. So these conditions are not there. So means, so in order to measure one physical quantity I will take correct instrument. So I am not making any kind of negligence while taking the reading. Environment is also not changing, means temperature and all the things vagera. So it will not get changes. Even though while measuring this physical quantity I will get certain kind of errors. So did you think why such things are getting happen here? True length of this object is 10 centimeter. I will give you correct instrument only. And I hope you are too much curious, means you are having too much concern about measuring the length here. So you are taking exact length, means you are not doing any kind of negligence. Even though, so you will not get that measured value as equal to that of true value. For example, true length of this object is 10 centimeter here. The same object if you are measuring from the measuring scale, so this is true value and measured value may not be exactly equal to 10 centimeters. So for example, so this may be equal to 9.99 centimeter if you measure first time, and if you measure the same object in the second time 9.98 you will get. So if you measure the same object 9.89 centimeter, like that you are getting. So why such different readings are getting appear? I don't know that. Did you get my point? So I will take that correct reading, means the correct instrument I am taking. I am not showing any kind of negligence. So surrounding temperature and all the things, it won't get changes. Even though I am getting certain kind of errors while measuring here. What do you mean by error here? The difference between true value is 10 centimeter, measured value is 9.9, 9.98, 9.89, like that. So even though certain kind of errors are get appear, so such kind of errors are random errors I will consider. I don't know definite reason for the errors. So such kind of errors are belongs to random errors here. So errors due to indefinite reasons. Errors due to indefinite reason. Errors due to indefinite reason. So such kind of error we will name it as random errors. So look at here, errors are due to indefinite reason. I don't know what's the reason for the errors here. So such kind of errors I will take it as random error. Then what shall I do here? So if that errors are appear, shall I leave that errors? No, it is not possible. Why? Because I won't get that exactness if I leave about that errors here. Then what suppose I have to do here? I have to minimize the errors. So keep it in mind. So while measuring the physical quantity with the measurement, means with that instruments, if you get certain kind of errors, I need to minimize the errors here. So what shall I do here? I need to minimize the errors here. Then how to minimize the error is the task here. So in order to minimize the errors, so we'll consider certain kind of mathematical steps to avoid the errors. So I hope you are having habit of calculating that mean value or average value. Did you know that what is the purpose of taking the average value or mean value here? So the purpose of taking average value or mean value is to reduce the errors here. So what is the main purpose? To reduce the errors. So if you take that average value, so errors will get minimized here. So that is the purpose of taking that average value. So look at here. So in order to minimize the errors, what are the mathematical tools I need to use here? So in case of random error, errors are get appear due to indefinite reason. So In order to avoid such kind of errors, we will use certain kind of mathematical steps to minimize the errors. So those are, first I will take that in case of random error, again I will take that types of random error. So first one is absolute error. So first one is what? Absolute error. What the mean of that absolute error here? So for example, I am measuring one physical quantity. So for example, I am measuring that length of this object. So I will take number of trials here. So first time I will measure its length is A1. If I measure that second time, its length is A2. If I measure that third time, its length is A3. So if I measure that n times here, so look at here, I want to take that if A1, A2 and A3 so on up to A of n are the measurement here. So now I want to take that average value or mean value. A bar is mean value. How to find that mean or average value? Number of trials here. So for example, A1 plus of A2 plus of A3 so on up to A of n divided by how many trials you done? So n number of trials. So this is the way to find that average value. Okay. So now I have to consider what you mean by absolute error. So that absolute error is, for example, I will take by symbolical representation delta of A. So that absolute error is nothing but it is that difference between mean value and observed value. Mean value is what? A bar here. Observed value is what? So A1 here. First trial is A1. Average value minus of observed value. So that will give about absolute error. What is that absolute error here? It is the difference between mean value and observed value. It is the difference between mean value is nothing but average value. It is the difference between mean value and observed value. So that we can call it as absolute error here. What is that formula here? Absolute error is delta of A is equal to A bar minus of A1. So similarly, for example, this one is delta of A2. So that is A bar minus of A2. Delta of A3 is nothing but what? A bar minus of A3, like that. So I have to find out that absolute error here. What's that absolute error here? It is the difference between mean value and observed value. So that is absolute error. Now I can take that mean absolute error. So mean absolute error means average of the absolute error here. Delta A1, delta A2, delta A3 so on. Delta of AN is equal to what? A bar minus of AN here. So now I have to consider what you mean by that mean absolute error here. So look at here. Next thing I need to understand about that mean absolute error. So what's that next thing? Mean absolute error. So that mean absolute error is delta of A bar I will consider. What's the symbolical representation? For my convenience I will take delta of A bar here. So modulus means I can take only positive value here. So look at here. What is that mean absolute error here? Arithmetic mean of all absolute errors. So arithmetic mean of all absolute error. So we can call it as mean absolute error. So look at here. So delta of A1 I said and delta of A2 so on delta of AN. So that is absolute error here. So mean absolute error means delta of A bar is equal to delta of A1 mod of means modulus of delta of A1 plus modulus of delta of A2 plus modulus of delta of A3 so on divided by n here. So that is mean absolute error. What this one is? So this one is mean absolute error here. So arithmetic mean of all absolute error. It means simply you can take that I have to find that average value of absolute error. So that is mean absolute error here. So next one is relative error here. So what's that next thing? So next thing I need to understand, that is relative error. So what's that relative error I need to understand here? So that relative error is nothing but, so it is the ratio of mean absolute error to the mean value here. So look at here, what is that relative error here? It is the ratio of mean absolute error to the mean value. So what's that mean absolute error? Delta of A bar is mean absolute error here. So relative error is equal to what? So relative error, so it is equal to what? Mean absolute error. It is the ratio of mean absolute error here. So modulus of delta of A bar divided by mean error is nothing but what? A bar here. So in order to take that absolute error, A1 plus of A2 plus of A3 up to so of A of n divided by n here. So that is mean value. So this one is mean absolute error here. So it is the ratio of mean absolute error to the mean value. So that is about relative error here. Next one is percentage error. So percentage error is nothing but what? So next one is, so I can find that error in terms of percentage. So that is percentage error here. So that percentage error is nothing but what? So relative error into 100. Relative error into 100. So that is nothing but percentage error. Or we can say that relative error is nothing but what? Delta of A bar divided by A bar into 100. So this is the way to find out that percentage error here. So I will give you some questions. So hope you will solve that.